Hello, I am here doing a video for you guys about theorems about chords. So we have three different ones that we're going to cover today. I'm going to go ahead and start with the first one. So the first one says if a diameter is perpendicular to a chord in a circle, then it bisects the chord. So we have a diameter and it's perpendicular to this chord, right? So because it's perpendicular and we can see here that it slices it perpendicularly, right? Creating that perfect T. Then these two segments are going to be congruent. And it just kind of does make sense, right? It makes sense that these two would be the same because this is going through it perpendicularly. So what that means is if that is 6 inches, then the other one would also measure 6 inches. Now that's important because we can create, you guessed it, right triangles. Every time when we have a perpendicular angle or a right angle, we can always create a right triangle. And that's a basis for us because as you keep seeing it, we always keep going back to triangles. So we can create right triangles here by drawing the radius of the circle, right, from the center to the point here on the circle, right? So let's look at an example. A chord in a circular clock is 12 inches long, and its midpoint is 8 inches from the center of the circle. Find the radius. So we have a chord that measures 12 inches long, right? Since it measures 12 inches long, when we draw this diameter going perpendicularly through it, then this becomes 6 and the other one becomes 6 as well, right? Because it's bisecting it. Its midpoint, so the midpoint of the chord is 8 inches from the center of the circle. So this is going to be 8 inches from the center. What we are looking for is the radius of the circle here. So let's look at an example. What do you think we're going to use to solve for the radius? If you said Pythagorean theorem, you guessed it correctly. So we're going to use a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse, which in this case is the radius. Okay, so here we have that 8 squared plus 6 squared equals c squared. 64 plus 36 equals c squared. 100 equals c squared. So what we do is we square root. So 10 equals c, right? So that means that the radius here is 10 inches. Next, we have circle 2. On the second case, we have two congruent chords. So in a circle, two congruent chords are equidistant from the center of the circle. What that means is that from the center of the circle to the chord, those two distances would be the same. So if we draw the radius, okay, we can prove this. Okay, so let me show you how we can prove that these two distances would be congruent. So first off, we have two perpendicular intersections here, okay? And next, we are going to use this as a midpoint, okay? Here, this is a midpoint of this chord, likewise over here. So now, First off, we know that the radius should be equal, right? Because it's the radius. The radius is going to be the same distance all through the circle. So we know those are congruent. Next, we know that, well, these two angles must be congruent, right? Next, we know that these two lengths at the bottom should also be congruent because initially we have these two chords that are congruent, right? So if I slice this one in half, right, these two halves should be congruent as well. So for example, if this was 10, then this half is 5, right? Since these two are equal, that one should also be 10, hence 5 should also be here, right? So with that in mind, we can prove that the two triangles formed here are congruent, hence the corresponding parts here should also be congruent. And we can prove that by saying hypotenuse leg. We have the hypotenuse is congruent, right? Which in this case, the hypotenuse of the triangles is the radius. And these legs here are congruent. And we have the 90-degree angle, hence the triangles are congruent by hypotenuse leg, which proves that these two are congruent as well, okay? These two lengths, meaning that if that is 3 centimeters, then that one should also be 3 centimeters. Now let's try an example. We're gonna go ahead and leave the 3 there, and then we're gonna say that the chord is 8, right? So if the chord is 8, then those two little pieces should be 4 and 4, because this is bisecting it, okay? So that should be 4 as well, and that one would be 4 as well. But we're only gonna look at one triangle at a time, okay? So let's see that we were looking for the radius. Then all I would have to do is use the Pythagorean theorem, you guessed it. So that would be a squared plus b squared equals c squared, again, right? So what we have is 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. And I'm going to come up here because I ran out of space. But 5 equals c. Right? Meaning that this is 5 centimeters here. And we didn't really have to work it out because remember I told you a special right triangle has lengths 3, 4, 5, right? So likewise, we can use that to figure out the length of this chord, right? If we were given 5 and 3, we would have been able to figure out that this is 4. If we double it, this is 8, right? And likewise, we would have been able to say, hey, then this chord over here is also 8. The last relationship is the third one that we see here. And we have intersecting chords in a circle have a special relationship such that a times x or ax times xb equals cx times xd. Okay, so the product of ax and xb should equal the same as cx times xd. Okay, and right now I know you're probably like, that sounds confusing, but it really isn't, okay? So let's just look at the chords first. It's just two chords intersecting, right? They're not going through the center. They're not doing anything special. It's just two chords, two random chords that intersect inside of the circle. So now what that says is that if I have two intersecting chords, then the product of the two segments in the line, in the same line, equal the product of the other two segments in the same line. So let me give you an example. Let's say CX measures 10 meters and XD measures 2 meters. AX is 5 meters and XB is unknown. Okay, so what we're gonna do there, right, is we're gonna use our formula here that says that, hey, AX times XB, right? AX is 5 times XB, that's Y. That equals CX, which is 10 times xd, which is 2, right? And all I did is I'm multiplying the numbers on the same line. 10 and 2 are on the same line, multiply them. That should equal the other two numbers on the same line, 5 and y. Okay, that's all I did. If they're on the same line, multiply them and equal it to the other numbers on the same line. So 5y equals 20, right? And then from there, all we have to do is solve, okay? So we divide by 5, and we end up with y equals 4, okay? So that means that y here, this measure here would be 4. So our final answer is 4 meters here. So that is all for this lesson, okay? I hope you were able to understand the 3 theorems. And go ahead and start working on the assignment, which I've posted in Google Classroom for your class. And I will see you guys Wednesday or Friday.